In this lecture, we'll talk about mutually exclusive events. So we have an experiment, for example, flipping a coin. We have a sample space, the set of all possible outcomes. Let's draw the sample space like this, sort of like a canvas on which we can have various events. So let's say that I have two events. My event A is this part here, and there is event B, which is over here. In this case, these two sets are disjoint. That is, they do not overlap. That means that they have no items in common. And since they have no items in common, they cannot both be true at the same time. The only three possibilities are A is true, or B is true, or we could have an outcome where neither is true, but it's certainly not possible to find an outcome where both are true. So for this particular case, we say that these two events are mutually exclusive. To summarize, two events are said to be mutually exclusive if they have no elements or outcome in common. And this in turn means that they cannot both be true at the same time. Here's a simple example. We roll a dice and the sample space is 1 through 6. I define two events, A and B. The first event is that the die will show a number less than or equal to 3. And the second event is true if the dice shows a 4 or a 5. These are mutually exclusive. None of the elements in A, 1, 2, or 3 can be found in B, and none of the elements in B, 4, and 5 can be found in A. C and D, on the other hand, are not mutually exclusive. They have the number 3 in common. So for the events C and D, it is possible that they are both true at the same time. If I roll a 3, then both of them will be true. Remember that when we have two sets like this, one set A and another set B like this, then the elements in common between A and B is called the intersection of A and B, and it's denoted by A cap B. For example, the intersection between C and D is a set containing only the element 3, while the intersection between A and B is empty. They have no items in common, and we write that using the empty set symbol. So we can see that the following is true. A and B are mutually exclusive if and only if their intersection is empty. If they're mutually exclusive, the intersection must be empty, and vice versa. If the intersection is empty, then we call them mutually exclusive.